Hello everyone, in this video I'm gonna solve IBHL Mathematics paper 3 questions from last year. This is the last paper in the exam and GDC is required for this paper. Formal booklet is also required. The maximum mark is 55. There are 2 questions in this exam and the questions based on proofs. So you need to be careful while you're working. Let's start by the questions. Start with the first question. It has maximum mark 27. This question asks you to investigate models for the population of trout in a lake. Trout is a type of fish. At the start of a year, a lake is estimated to contain 6,000 trout. The owner of the lake estimates that the number of trout will increase by 10% per year. At the end of each year, the owner proposes to remove 500 trout from the lake to prevent overpopulation. Therefore, the relationship between Tn, the predicted number of trout at the start of year n, and Tn plus 1, predicted number of trout at the start of year n plus 1, is given by, here is an equation. For example, the predicted number of trout at the start of the second year is given by, when we apply this formula, use this formula to verify that T2 equals 6,100. Yeah. So we just apply T2. It's gonna be 1.1 times 6,000 minus 500. And here is 6,600 minus 500 is gonna be 6,100, right? So we found T2, verify that T3 equals 6,210. I'm gonna copy this page. Yeah. Yeah, we're gonna find now T3. So T3 gonna be 1.1 times T2 minus 500. We found T2 at the previous question, 6,100 minus 500. So let's find this. You are allowed to use GDC. Yeah, 1.1 times 6,000. Was it 600? Oh, 100 minus 500. Yeah, this is 6,210. 600, I mean 6,210. Yeah. Find T4. T4 equals 1.1 again times T3 minus 500, which is 1.1 times 6,210 minus 500. We are just gonna write here. Yeah, this is 6,331. 6,331. Yeah. It's also known that Tn equals, there's an equation also here, show that Tn equals, yeah, we're gonna show this. First, I'm writing the equation which is given to us. Minus 500 in parentheses 1.1 to the power of n minus 1. Yeah. So, yeah, find this, which is 0.1. And in this case, Tn, we can write in denominator 0.1, and when you multiply 0.1 by 6,000, it's gonna be 600 times 1.1 to the power of n minus 1 minus, and multiply it by minus 1, 500. Yeah, let's write it to the down. Yeah, 500 times 1.1 to the power of n minus 1 plus, it's going to be plus 1. So you can write 100 times 1.1 to the power of n minus 1 plus 1 divided by 0.1. So it will be 1000 times 1.1 to the power of n minus 1 plus 1, right? Oh, sorry, we forgot to multiply 500 with minus 1. So here is gonna be 500 also. And then the solution will be this. Yeah. Hence or otherwise find T6, give our answer to the nearest whole number. So we can use this formula, right? And we're gonna substitute 6 into the n. Yeah, let's find this one. Mm. 1000 times 1.1 to the power of 5 minus or plus 5,000, was it? Yeah, plus, which is 6,611. 6,611, yeah. This is the second one of C. Let's continue from here. After deciding that the trout population will increase too quickly, the lake owner proposes instead to remove 750 trout at the end of each year. The relationship between the n, the predicted number of trout at the start of year n, and the n plus 1, the predicted number of trout at the start of year n plus 1, is now given by, this is the equation. It's also known that the n equals this expression. Show that the n plus 1 minus the n equals this. Okay. Yeah. So in here, we're going to show, let's first find what is the n plus 1, and we're going to substitute or plug in n plus 1 into the expression which is given in the question. So it's going to be minus 1,500 times 1.1 to the power of n plus 1 minus 1. In this case, we can write minus 1,500 times 1.1 to the power of n plus 7,500. In this case, we can also write what is the n. It is again minus 1,500 times 1.1 to the power of n minus 1 plus 7,500. So when we make subtraction here, the n plus 1 minus the n gonna be, so let's think about that. Here is common factor 1500 times 1.1 the power of n minus 1, and I'm opening a big parenthesis. In this case, you will write inside minus 1000, or no, we already write the out of the parentheses. And yeah, just I will write 1.1 from this one is coming, and that's it. Yeah. Sorry, minus 1, because these are canceled, and for the other factor of this, it will come a 1. So this is gonna be uh it's gonna be times 0.1. And from here you can write 150 times 1.1 to the power of n minus 1, right? Yeah, correct. Yeah, at the second question of D, use the result in part D1 to deduce that the predicted number of trout at the start of any year will be greater than the predicted number at the start of the next year. It means it is decreasing. So actually, this is already mean the n plus 1 minus the n, which is we found negative 150 times 1.1 the power of n minus 1. If we show this that is less than 0, in the this means the number of trout is decreasing, right? So how we're gonna show this? And you can actually just write, let's say, since any power of 1.1 is greater than 0, minus 150 times 1.1 to the power of n minus 1 gonna be less than 0, right? So we prove it. Yeah. At the other question, E, determine the first year during which there will be no trout remaining in the lake. The first during which there will be no trout remaining. So we use an equation which is the n equals this one. One is 1500 times 1.1 to the power of n minus 1 plus 7500. So we are looking for where is gonna be 0. We can draw a graphic for this. Minus 1500 times 1.1 to the power of, you're gonna write to the calculator not n, x, plus 5000 or 7500, right? Let me check it again. Yeah. Let's throw this one. So it's coming like this. And you can say here is 17.88, but it's asking for which year? The first year during which. So it is inside n equals 18. Yeah. or you can say it during the 18th year. Yeah, it's continue like this. I will also copy this question from here. The lake owner now considers a more general approach where the trout are removed at the end of each year. Let's see and then denote the predicted number of trout in the lake at the start of the end year where, yeah, this is the equation. Find the value of D such that the predicted number of trout at the start of each year is constant. So yeah, to do that, we know this equation is given. Sorry. And is asking for the predicted number of trout at the start of each year is constant. It needs to be, it means that there is no variable like n to cancel it. And since the constant of this variable is 6,000, I want this constant also 6,000. In this case, you can just write 6,000 equals 10D. From here, D must be 600. So when you plug in 600 into the D, you will find 6,000 times 1.1 to the power of n minus 1 plus 6,000, which is every year it is constant to 6,000. At the question G, the model predicted numbers of trout the lake owner has been using sequences generated by un plus 1 equals r times un minus d, where d and r is a positive real number and r not equals to the 1. Use mathematical induction to prove that this equation. Yeah. So how are we gonna use this mathematical induction? We are starting first to check if it is true for n equal 1. What's happening if n is 1? We are just plugging 1 into the n in this expression here. Minus d times r to the power of 1 minus 1 minus 1 divided by r minus 1. So here is gonna be 0, and then u1 equals u1. So we show that it is true for n equal 1. So you can say for n equal 1, you can maybe write here, for n equal 1, the expression is true. So you are continuing to the induction by saying let n equal k, that is true. It means you can write k, uk equals u1 times plug in k into the n, r to the power of k minus 1, uh, minus t to the power of r to the power of k minus 1 divided by r minus 1, right? Yeah. We assume that for n equal con is true. If we show that the expression is true for n equal k plus 1, then the proof is finished. So try to use our goal is to show for k plus 1, which is u1 times r to the power of k minus d times r to the power of k minus 1 divided by r minus 1. So what we know from the question, we also, yeah, actually from the previous one, we let that uh, this equation is true. And from also, it's given that the equation un plus 1, which you can also, maybe it's better to write in here for k. uk plus 1 equals r times uk plus t, right? So actually, we both assume that is true. And then in the question at the left in here, you can show that or plug in into this uk the equation which we let through u1 times r to the power of k minus 1 minus d times r to the power of k minus 1 minus 1 divided by r minus 1. So we'll let this through minus t, and let's simplify if it is equals this one. So we are just multiplying by r, u1 times r to the power of k, d times r to the power of k minus r divided by r minus 1 minus t, right? And then in here you can write u1 times r to the minus k minus t. This is the common factor, and out of the parentheses you can write here, and then you can say r to the power of k minus r divided by r minus 1 plus 1, right? Which is u1 times r to the power of k minus d times, in parentheses, r to the power of k minus r plus r minus 1 divided by r minus 1. So these cancel, and u1 times r to the power of k minus d times, it means r to the power of k minus 1 divided by r minus 1. So we show it, right? Yeah. Question 2, it has maximum 28 mark. A polynomial is said to be palindromic if the sequence of its coefficients remains the same in reverse. This question asks you to investigate some properties and solutions of palindromic polynomial equations. In part A and B, consider quadratic equations of the form ax squared plus bx plus a equals 0, where a does not equal 0. The sequence of coefficients ab and a remains the same in reverse. Following table shows three palindromic quadratic equations and their sequence of coefficients. Quadratic equation 2 times x squared minus 5 times x plus 2 equals 0 has roots 2 and 1 over 2. These roots form a reciprocal pair. Since one root is the reciprocal of the other, determine the roots of, x squared plus 4 times x plus 1. Give these roots in the form like this. So let's start with this question. Yeah, from here we can say In the question A, x squared plus 4 times x plus 1 equals 0. So we can check the discriminant. What was discriminant? Let's remember it. It is b squared minus 4 times ac, which is the roots of, examining the roots of a x squared plus bx plus c equal 0 equation. So the delta in here equals 4 squared minus 4 times a is 1 in here, b is 4, and c is 1. In this case, I'm going to write like this. It is 16 minus 4, 12. So the roots of equation, the roots 1 and 2 equals minus b plus and negative square root of the discriminant divided by 2 times a. In this case, I'm gonna find first the root, which is minus 4 plus square root of 12 divided by 2. You can also write minus 4 plus times square root of 3 over 2. It equals minus 2 plus square root of 3. The second root of this equation is minus 4, now minus square root of 12 over 2. It is minus 4 minus 2 times square root of 3 over 2 equals minus 2 minus square root of 3. So we find this, yeah. Hence, or otherwise show that these roots form a reciprocal pair. So you can say that when we multiply these two roots, it means minus 2 plus square root of 3 times minus 2 minus square root of 3. It's gonna be 4 minus 3, right? Which is 1. In this case, we show that then roots are reciprocal, you can say, yeah. At the question B, show that the complex roots of x squared plus 1 equals 0 form a reciprocal pair. X squared 1 plus 1, x squared plus 1 equals 0 means x squared equals minus 1. You can say these roots is I and minus I. So in this case, again, the first root times the second root is gonna be I times minus I, which is minus I squared is 1. Then roots are reciprocal pair. Yeah. Roots form a reciprocal pair. Yeah. Let px equals a times x squared plus b times x plus a. Verify that px equals that. A times x squared plus bx plus a. Yeah. And then we will show that x squared times p o 1 over x. Yeah. So what is p 1 over x? You're going to plug in 1 over x into the x. B times 1 over x plus a times 1 over x squared plus b over x plus a. So when we multiply x squared with p over 1 over x, it's gonna be, let's find it, it is a plus b times x plus a times x squared means p of x. Yeah, we show it. Yeah, the other question, yeah, this is the other question. Let's solve this too. In parse DNA, you may assume the result that the polynomial P(x) of the Grian is palindromic if and only if, yeah, there is this equation. Use P(x) equals x to the power of n times P(1 over x) to show that if alpha does not equal 0 is a root of P(x) equals 0, then 1 over alpha is also a root. So if alpha, or you can say let's uh, P alpha equals 0, which means is a root of P(x) and of this equation. You can also plug in this alpha into this equation, then P of alpha equals alpha to the power of n times P of 1 over alpha. Since here is 0, and you can say since alpha does not equal 0, it means P of 1 over alpha gonna be 0, right? Because the left side is 0 and needs to be 0 at right side too. And in this case, we show that, and you can say 1 over alpha is also a root, yeah. Yeah. Let f of x equals p of x times q of x, where p and q are palindromic polynomials of degree n and m, respectively. Show that f is a palindromic polynomial. Yeah. So f of x equal this one. And we know that p and q are palindromic polynomials, which is p of x equals x to the n times p of 1 over x, and q of x equals x to the m because the degree of the q is m times q of 1 over x, right? Yeah. So when you multiply these two polynomials, it's gonna be like this, and then you can say x to the power of n plus n times p o 1 over x times q o 1 over x, and from where you need to say that x to the power of n plus n times f o 1 over x already given that, because I know this is f o 1 over x, right? So we also prove it. And here is the last part of this question. Yeah, I'm gonna use this page. Consider the palindromic polynomial f of x. This polynomial can be represented in the form, yeah, where u and v is a complex or integer, right? Yeah, it's integer. By forming and solving an appropriate system of equation in u and v, determine the value of u and the value of v. So yeah, f of x equal x to the power of 4 plus 2 times x cubed minus x squared plus 2 times x plus 1. And it says equals x squared plus u times x plus 1 times x squared plus u times x plus 1. In this case, we'll just, how can we say that, make some working at the right side. It's gonna be x to the power of 4 plus x cubed times v plus x squared. Just be careful, don't make mistake between u and v. And this is gonna be plus u times x cubed plus u times v times x squared plus u times x, right? Yeah. And by 1 again, I'm multiplying that. It's gonna be x squared plus vx plus 1. Yeah, vx plus 1. So if you equal these terms by 1 by, which means let's simplify right side again. If it's x cubed times u plus v, yeah, just these terms, plus x squared in parentheses 1 plus u times v, right? And this one plus 1 also. Maybe you can just cancel what you write to not make mistake again. Something else? No. And then x in the parentheses, you can write u from here plus 1 from here. And the constant is 1. Yeah. So now we can generate equation by 1 by, which means u plus 1 gonna be 2 and minus 1 gonna be here 2 plus u times 1, I mean v. And yeah, that's it, I guess, because u plus v already we say 2. So from here, u times v equals minus 3. For example, v equals to minus u, and you can write in here, plug in 2 minus u into the v. It's gonna be 2 times u minus u squared equals minus 3. U squared minus 2 times u minus 3 equals 0. It will be u minus 3, 1. The factors of this quadratic is u minus 3 times u plus 1, gonna be 0. It means u can be 3, u can be minus 1. And we say that v greater than u, for example, In this case, in here, we gonna be -1 because we know that we are close to -2. And in here, we gonna be 3, right? Yeah. So our condition is attribute for this one. Yeah. It means u equals -1, v equal 3. Hence finds all the exact complex and purely real roots of the equation. Yeah. So if you see hence, it means it is related with the previous question. What we found in the previous question, f of x equals this factors. X squared, u is -1 plus 1 times, I'm writing this one by the way, x squared and plus 3 times 6 plus 1, right? Yeah. So we can solve the equations separately. First one is x squared minus x plus 1 equals 0. And the second one is x squared plus 3 times 6 plus 1 equals 0. And again, we are looking for the discriminant of this equation. And I know the coefficients of this equation. So b is -1. In this case, -1 squared minus 4 times 1 times 1, which is 1 minus 4 equals -3. In this case, our roots are the first one and the second one is minus b, which is +1, plus and minus, square root of -3 divided by 2 times a is 1. In this case, I know that 1 plus and minus, this is the complex number, square root of 3 times I divided by 2. And here, this discriminant is 3 squared minus 4 times 1 equals 9 minus 5 equals 4. And then, equals 5, because here is 4. And then our roots, again, you can say 3 and 4, third and fourth, and -3 plus and minus square root of 5 divided by 2, right? Yeah, we found all of the roots of this question. Consider the palindromic polynomial equation. Consider the palindromic polynomial equation, whereas n is odd. Show that -1 is always a root of this equation. Yeah, it's going like a2 times x to the power of n minus 2 plus a3 times x to the power of n minus 3, a1 x plus a0, right? a1 times 6 plus 1 equals 0. N is odd. The number of terms is even here, which means you can divide it by 2. A2 times x to the power of 3. I mean, 2. Yeah, something like this. So means -1 to the power of n plus a1 -1 to the power of n minus 2. So for example, here A2, here minus A1. And since n is odd, it means minus 1. And here is A1. And here is minus A2. So it's going like minus plus or negative, positive, negative, positives. And then so you can say that um, there are how many terms? You can say n plus 1 terms in this equation, which is even number when these terms divided by divided or are separated, you can say, into the two groups. The coefficients of these terms are reciprocal in terms of some operation by and or respectively, which means sum of all terms equal 0. Yeah. You can just say opposite, respectively, which means sum of all terms equals 0. Yeah, you can say like this. Yeah, we saw all of the papers, questions from last year, IBHR Mathematics, and I hope it was helpful for you. And you're gonna make practice until take the exam in this year, which is gonna be on the 10th of and 11th and 14th of November. And wish you good luck in this exam. And I want you to share my videos with your friends and see you in other videos. Take care. Bye bye.